Hello good people, I'm going to look at a percent change problem that I'm sure everybody will find relatable and applicable. The number of fairies in a frolic has increased by 12% to 140 individuals. How many fairies were in the frolic before the increase? I'm going to start by creating a roadmap. I do not know how many fairies there were at the start, but I do know that their number increased by 12% and that resulted in 140 individuals. There is a common pitfall here, and that would be to calculate the 12% of 140 and then subtract that from 140. We cannot do that. In percentage problems, we always need to ask ourselves, what does the percentage apply to? And in this case, the 12% applies to the unknown starting number. After all, it was the unknown starting number of fairies that has increased. I can say that the original number of fairies, well, that was 100%. To that, I'm going to add 12%, which means I will end up with 112%. And now I could say that 140 represents 112% of the original number. Let me write that. 112% of the old number of fairies is equal to the new number of fairies. I cannot do much mathematics with this. So let me substitute some of these words with mathematical symbols. I'm going to leave 112% for now. Of usually implies a multiplication. Old, well, that is the unknown. Is the same as equals. And the new number of fairies is 140. 112% can be written as a fraction, and that would be 112 over 100, still multiplied by x, equals 140. 112 divided by 100 is 1.12, multiplied by x equals 140. And now I need to transpose 1.12. I'm currently multiplying, so to transpose it, I need to divide by 1.12. On the left-hand side, I will be left with x, and on the right-hand side, 140 divided by 1.12 is 125. I can say that the original frolic contained 125 individual fairies. Why is it that I can't just calculate 12% of 140 and subtract it from 140? Well, let's try that and see what we end up with. 12% of 140 is the same as 0.12 multiplied by 140, and that will give me 16.8. While 16.8 is a fine number, it doesn't quite work within the context of the question. I cannot have 0.8 of a fairy. So I'm going to round to the nearest whole number, and I'm going to say that this is 17. I can now subtract the 17 from 140, and that will give me 123. So this working out suggests that there were 123 fairies to begin with. Let me apply a 12% increase. 12% of 123 is the same as 0.12 multiplied by 123. And that will give me 14.76. Once again, I'm going to round to the nearest whole fairy, and that will give me 15. If I add the 15 to the 123, I will end up with 138, not the 140 that the question originally gave me. And this is why we cannot use this approach. Whenever we are dealing with a percentage question, we need to ask ourselves, what does the percent apply to? In this case, the 12% applied to the original unknown. We cannot just apply it to the given new value. That is all for now, and I will see you on the flip side.